Welcome. This is the first independent climate investigation of this quarter. So before I really jump in, let me just explain a little bit how this works. This class is a 5-unit class, meaning that we are supposed to meet, at least in lecture terms, we're supposed to meet for 5 hours a week. Based on much of the feedback I've gotten as a teacher, having 2.5 hour meetings was a little bit too much for students. So what I did was I shaved off an hour and made that an independent hour. And so the activity that you're doing here makes up that 5th hour. And then the other 4 hours are the Zoom meetings that we do. So that being said, let's jump in and talk about this independent climate investigation. So we'll do 6 of these things throughout the quarter. And then during even weeks, weeks 2, 4, 6, 8, and 10, we'll be doing quizzes during this time. And they'll be open book, open note quizzes, so don't worry about that. But just know that that is how this class is going to be designed. And with that said, let me introduce our first activity. So in class on Wednesday, we discussed the scientific method, and I told you a lot about what goes into good science. How is it different from pseudoscience, which is actually one of our SLOs? And so what you are tasked to do now is to actually design your own scientific experiment. Here's the good news. You don't have to carry out your experiment. Let me say that again. You don't have to carry out your scientific experiment. The reason why I'm stressing that so much is because I don't want you to feel limited to something you only have the resources to do. You can use whatever you want, however long you want, wherever you want. It is completely up to you. The way that I'm grading this is 1, satisfactory completion, meaning did you adequately answer what I'm asking you to answer? And then 2, were you respectful and constructive in the feedback that you give to the other participants in your group? So let me explain how this is going to work. Let me click on ye old share screen here. So this is actually a group discussion. Now let me stress, not all climate investigations are going to be group work. Not all of them are going to be discussions. So I know when people hear the word group or they hear the word discussion, they kind of run for the door. I promise you it's not that bad. So here's what you're going to do. For this investigation, you are going to develop your own scientific experiment. You're going to post that as a response to this prompt, so as a discussion post. And then what you're going to do is you're going to then reply to your group mates, the other people in the group, what they put down, that you're going to respond to their investigations. And so the good news is that your grade does not hinge at all on other people. I grade them solely on what they say. I grade you solely on what you say. So you don't have to worry about losing points because somebody slacked off. That's on them, not on you. But let me explain how this is going to work. So this will open at 11:20 a.m. right as class ends on Wednesday. And it's due by, 11:20, 1:20, I lied. 1:20 p.m., so right after class ends on Wednesday. And it's due at the time we meet next Monday, which is September 28th. The way that it works is you're going to answer this prompt right here. The prompt is to propose, design, explain a scientific experiment that you would use to test the following question. Is it usually cooler near the ocean than it is inland? So what I'm trying to get you to test here is, a lot of people say that it's colder near the ocean, colder near the beach than it is further inland. So your experiment is going to test that. Is it colder near the beach? Is it colder further inland? That's what your experiment is going to do. what you're going to do is, in a post to this discussion, you're going to write down an experimental design providing 5 things. The first thing is you can't even do a test without a hypothesis. So you need to make a hypothesis. Maybe your hypothesis is it's cooler in the afternoons, warmer at night. So that would be your hypothesis. Or maybe, no, it's cooler inland than it is near the coast. So whatever your hypothesis is, and you don't have to do any research for it, just based on your own knowledge, based on your own background, based on what you have experienced, that's your hypothesis. Then what you're going to do is you're going to then explain your experiment and how it tests your hypothesis. So for example, if you say it's cooler near the beach in the afternoon, but you do your experiment at 6 a.m. in the morning, that's not going to test your hypothesis. You would want to do your experiment at noon rather than, you know, or whenever you say in your hypothesis you're going to do it. Okay? Then you're going to describe what your plan is for your experiment. So here you're going to say, I'm going to take the temperature of 10 different places, or I'm going to take the temperature at 10 different heights. I'm going to take the temperature at different times throughout the day. So that's what I'm looking for there. Then where do you plan to do it? Don't just say, I'm going to take one temperature near the coast, one temperature inland. Actually pick a few places. You can do it just locally in California, or you can do it across the nation. You can say, I'm going to pick 10 coastal cities, and I'm going to do it on the coast, and then I'm going to do it 50 miles inland. But make sure that you explain that. Then, how long do you plan to do this for? One of the key facets of good scientific research is that you've done it for a long enough period of time. If you remember in class when we talked about pseudoscience, pseudoscience is oftentimes only based on one instance. So if you're only using one instance, if you're only going to do it once in one location for one day, that's not enough data. You need a decent amount of data. The typical rule is nothing less than 30. You want to have at least 30 instances. And those of you who've taken statistics probably already know that. Those of you who haven't taken statistics, that's okay. Just know you need at least 30. And then finally, what kind of equipment do you plan to use? I'm not going to be strict about, I'm going to use a Kestrel scientific meter with a tripod at 2,000 feet. Like, just briefly describe what kind of an instrument are you going to use. Don't just say a thermometer. Say, I'm going to use a glass thermometer mounted on a pole at a certain height, and I'm going to have somebody read it every day. So make sure that you describe what you're using to do this experiment. And so what I recommend is don't spend more than 40-ish minutes on this. You're not writing a great American novel. I'm looking for 150 to 250 words. That's not even a page. Just answering these different things. And then finally, once you've done that, you may have to wait a couple of days until your group mates have responded, or you can all discuss when you're going to do it. But then what you're going to do is you're going to reply to each group member. You're going to read their experiment, and then you're going to provide feedback on it. So let's say somebody else says, I'm going to do it for San Jose and Santa Cruz. And then you say, okay, well, that's good for over here, but why don't you do it for a few other places as well? Like making a suggestion. So that's all I'm looking for there. And that only has to be about 50 words long per person. So you're going to reply to each person. And once again, I'm not expecting you to write a great American novel. The only thing I ask is that your feedback is constructive and that it's respectful. Don't badmouth anybody else. If you're rolling your eyes as you're reading their experiment, keep that to yourself. Still try to provide meaningful feedback, helpful feedback. Okay, I do have some things to consider down here, as well as a criteria for how I'm grading this. I'm grading this mostly on completion. Did you do it? And did it meet what I'm looking for? Did you give me a hypothesis? Did you describe an experiment? Did you tell me what kind of equipment that you're using? Once again, I'm not looking for perfection here. One of the things we're going to do in a future investigation is we're actually going to refine these experiments and create something a little bit more concrete. And one of my goals would be maybe towards the end of the quarter, we have like a full experiment put together. Even though we don't have the resources to actually do the experiment, it's kind of fun just to, hey, if you have no limits, no money limits, no anything, what would you do? Be creative with this. Have fun with this. Don't feel like it's a super stressful thing. If you're stuck on anything, don't hesitate to message me. Don't hesitate to ask me. But also, don't stress too much about this. I don't want this to be something that has you running for the door. All right. So that's that. If you have any questions, comments, or concerns, please drop me a line. I'm happy to help. Otherwise, good luck with this. And I'm excited to see how it goes. And it's the first time I'm doing this. So if this is a disaster, that's not on you. That's on me. All right. So best wishes as you're doing this. And I'm here to help.